Alrighty, friends. Good morning, afternoon, evening, time of day you're deciding to trudge through these videos. So hopefully, within our sort of lecture two material, you have since learned now some systems terms, some system terminology, right? So flux, reservoir, influx, outflux. What do these things mean? Refer back to that. The beautiful thing about these being on YouTube is you can always refer back to them at your leisure. And repeat them until you're so sick of hearing my voice and seeing my face. And then I finished off that video looking at this idea of feedback loops. So I'm going to revisit that and then give you a lovely example of a feedback loop of something you probably have experience with in your everyday life, or at least if you've ever been in a building or a vehicle before. So just reminding ourselves what a feedback loop is, right? So we have two different kinds, positive and negative. So kind of break your connotation or your idea of what positive means versus what negative means, right? Because in this case, it's not necessarily a good or a bad thing. What I would like for you to consider here is that of a thermostat. So I know it says discussion topic, but I want you to kind of think of this idea of how does a thermostat act as a feedback loop? So this idea of a reinforcing or a balancing sort of act here. So say you have the thermostat as a feedback loop, right? So you have a room at a certain degree. If the temperature in the room goes up, then this thermostat will turn the air conditioner on, which will cool the room, right? So you have this perturbation, right? The temperature goes up a little bit. So, maybe you have like a classroom, a whole bunch of students cram into this room. So now the room is warming up a little bit. Then the thermostat is like, hey, it's too warm in here. Let me kick on, which will then cool that room down. So what do you think that this is an example of? Do you think this is a positive or a negative feedback loop? Think about it. Pause the video for a second and really think about this idea. Do you think this is a positive or a negative feedback loop? If you said a negative feedback loop, you would be super correct, right? So this is a dampening response. So the room heats up beyond what the thermostat is saying is okay. And then the thermostat is like, hello. And so the air conditioner turns on and cools down the room. So it's a balancing act, right? Balances that system very nicely. So similarly, let's think about the opposite way, right? So say the temperature in this room goes down. Say it's like the sun goes down and it's nice and cold outside now, which then cools the inside of the room, or it's wintertime, whatever. And then within that, of course, then something's going to happen. The furnace turns on and heats the room back up to what it's supposed to be. So once again, would that be an example of a positive or a feedback or a negative feedback loop? Take a pause. Think about it. What do you think? Did you think it was a positive feedback loop? You would be incorrect if you did. It's actually a negative feedback loop, right? Because it's also acting as a stabilizer. So just because, a thermostat is cooling down a room or heating up a room, it can still be a negative feedback loop, right? So maybe that's another thing that we need to kind of break this connotation when we're thinking about feedback loops. When we think about ones in nature, I think the biggest one we always think about is climate change and global warming, and it being like a positive feedback loop and always increasing. But we also need to remind ourselves that it can also be a cooling effect as well, and kind of be it doesn't have to be necessarily one or the other. So it can be, so it's really quite fascinating, I think. Or a negative feedback loop, can be a warming or a cooling effect. And so can a positive feedback loop also, kind of going back to what I was saying before. So similarly, which type of feedback loop do you think the hot water heater would be in our discussion of the bathtub situation before? Right? So, you have this hot water heater, the water heats to 104, the water heater turns off, water cools to 102, it turns on, etc., etc., etc. So this again would be an example of course, a negative feedback loop. But say your hot water heater broke and it doesn't turn off once it gets too hot, then it continues to heat up and heat up and heat up and heat up, and then you turn on the shower and you burn your skin off, right? That could be an example of that loop breaking. Or the opposite direction. It doesn't, the hot water heater's pilot light turns off or whatever, and so the water gets really, really cold and doesn't heat up to what it should be. So negative balancing feedback loop, again, is holding a system to an equilibrium state and making it more stable, whereas a positive feedback loop tends to move the system away from equilibrium and making it more unstable. So some examples of positive feedback loops in environmental problems, of course, loss of biodiversity and melting of land ice. Some big things here. I think the land ice situation is the one we often think about quite a bit. We think about, more land ice melting exposes darker land underneath, which makes the region warmer, which melts more ice, which exposes more land, which makes it warmer, etc. So that's a very important feedback loop there. And then really to address any of these issues, we really need to consider all the complex interactions rather than just merely one component alone or a single cause and effect relationship. So when we're talking about things like climate change, we really have to remember that it's way more complicated than just, just put more ice there, or let's shield the earth from the sun's rays, or let's spit aerosols into the sky to make more clouds to cool it down. It's so much more complicated than that. And it's a really, really big point that we often forget, I think. And that's why a class like this is really important, to remind ourselves that these interactions between each other are super, super important and very complex, right? And we don't fully understand a lot of these interactions, right? So what we do in one area can completely down the line impact and maybe even devastate something else down the line for just one little action. Kind of like butterfly effect sort of feel. This is also, of course, an essential tool for addressing societal changes, right? When you're thinking of things like energy, food, and water resources, again, poverty, climate change, hazards. There's never one silver bullet to fix homelessness, right? That's a big issue here in San Francisco, California. It's just move them from one place to another. Okay, well, that doesn't solve the problem, right? So you're just you're moving things around. You're not actually doing anything to solve the issue. And of course, a lot of these challenges cut across just human and natural systems. They can involve multiple interdependent variables and feedbacks that are changing over time and space, and of course are critically important, yet are very complex to predict, right? So a lot of these ideas, again, in your everyday life, and things that we as a society deem as scary or whatever, are really complicated. Right? Even think of your own internal body, right? It's a complicated thing. But she's there, she's doing all right. She's hanging in there, but one little thing can cause something crazy wild down the line. How your teeth are connected to your body, right? If you don't take care of your teeth, that can cause heart problems down the line, where your teeth ain't in your heart, right? So similar sort of idea. Again, sorry, I'm a little delirious at this point, so just the analogies are just coming out of nowhere. So recalling today's goals, right? So I wanted us to start by defining our systems terminology. So we did that in our first video, reading and interpreting simple systems diagrams, and then evaluating a diagram's fit into the description of a system. So this is what you're going to do. So there is an assignment associated with this that I would love for you to complete before we return back together. I know there's kind of a lot to do, so that's why I've kind of kept these lecture 2 videos kind of nice and short and concise, so you have time to complete these other assignments. Okay, so the feedback loop assignment that I have associated here is there's an assignment on Canvas where it links to an audio clip of some folks talking about wildfires, and there are aspects of that I want you to try to identify as being the fluxes, the reservoirs, and how like feedback loops can kind of make their being known. There's all the details to that in the assignment that's linked on Canvas, which you should have access to very soon, if not already. So there's that. So that's like part of this sort of like lab material here. And then I'll go towards like your lab part of your grade. And then when we come back, we'll revisit that idea and I want to see what you all had to say. So please do this assignment before we come back on Tuesday. That would be fantastical. So that, all of the introductory assignments, which I already mentioned in a previous video, lectures 1 and 2 assignments, which won't be super long, I promise. It's just like a couple point assignments to make sure you watch the videos. And then 3 is skimming over that tropical cyclone and climate change paper, and then we'll revisit that idea. If not when we return on Tuesday, then certainly on Thursday, just to kind of get us vamped up with skimming through articles and with content that will hopefully be relevant when we start to return. And what's it called? Tropical cyclone season really ramping up. So again, if you have any questions on anything, any of the assignments or anything like that, please reach out and let me know, and I'm happy to assist in any way possible. So thank you so much for watching and for your attention. I super appreciate it. I'll see y'all on the flippy floppy. Bye.